Suppose you want to find the population mean of something, mu. If you were to try to, guess that based on just one number, if you were to give one number that gives you your best guess for that, that's what we call a point estimate. And usually the best guess for mu is just x bar. So if you wanted to know the average SAT score among everyone who took the SAT, you want to know the mu. But if you were to just ask, a couple hundred people and you have that average, that's your x bar. So that's called a point. So this is a point estimate for mu. Now the problem is, that's just one sample and you're really not sure. You're not confident that, this number is even close to this. I mean, it's your best guess, but who knows? What if you got the people in your sample happen to just by random chance be the lowest performers or the highest performers, and you really don't know if this is representative of this. So, if x bar is representative of mu. So a much safer thing to do than to give just a point estimate is to give what's called an interval estimate. And that's where the concept of a confidence interval comes in. Long story short, we want to know mu. We don't know what mu is. We got x bar though. So we're going to say that our best guess for mu is that it's somewhere in this range. And that range is always going to be centered at x bar because, again, that's the one number that's our best guess. But it's always that plus or minus what's called a margin of error. Margin of error. Right? So, which is, you can call it ME or something just for short. But yeah, but that plus or minus your margin of error, and in a sec I'll show you how you can calculate that margin of error. But basically, that's the concept. That's how you find the average, a sensible interval estimate for the average. Notice, so usually this is, based on a certain level that you've predetermined. Let's say you want to be 95% confident. So notice this isn't saying like 95% of all the data fall within this confidence interval. No. Basically, this is saying we are 95% sure that the one true mean, this number, is somewhere in this range. Right? Well, we're not saying anything about the overall distribution of all values. We're just talking about the one number, the mean. The one mean is in this range, with 95% confidence or 99% confidence, whatever you chose. So basically, the margin. How do you find the margin of error? Well, the margin of error is essentially your standard error times your z. And you might use t instead of z. The next video talks about exactly the difference between those. But these are what we call test statistics. So that being said, the z or the t that you're going to use for a confidence interval is essentially predetermined based on the confidence level that you choose. So first of all, before we get into the weeds with this, conceptually, if you want to be more confident that your one true mean is somewhere in this interval, the only way to be more confident, without collecting a higher sample size, that is, more confidence is to have a wider interval. Right? So if we want to be pretty sure that the average, let's say SAT score, the average SAT score, if we want to be, 99% confident that it falls somewhere within this interval, then that's got to be a broad interval, so that way you're really sure that it's somewhere within there. But notice, broad intervals are also not as useful in practice. If I were to, if you're running for office and you're asking, hey, what percent of people want to vote for me? And you get a sample and you're like, oh yeah, the interval, the estimate is anywhere from 43 to 65% of people want to vote for you. That's all we know. Well, that really doesn't help because you don't know, that's too broad of an interval. You don't know if you're going to win or not with confidence. And so, but on the other hand, if the interval was, oh yeah, anywhere from 53 to 55% of people are going to vote for you, well, those narrower intervals are better because they're more precise. But the problem is, the more precise the interval, the less confident you are that the overall, the true population mean is somewhere in there. And so there's this trade-off between accuracy, whether you've got the mean in your interval or not, accuracy and precision, how narrow your interval is. So that being said, what is the margin of error? So the margin of error is your z times your standard error, and your standard error, remembered, is s over root n. And so this z specifically is either going to be 1.96, 2.57, or technically 1.65. So it's going to be one of these three numbers based on how confident you want to be, based on whether you want to be, if you want to be 90% confident, 95% confident, or 99% confident. Of course, if you want to be 98% confident or some number other than these three, you could look up on the z table what value you have to choose. But essentially, the most common thing is the 95% confidence interval, so 1.96. And, if it's not something that you need to be super duper precise about, a lot of people just round that to 2. So overall, for all practical purposes, the margin of error, the thing that you're going to plus or minus from your sample mean to get your interval, is basically 2 times the standard error. So because that's sort of what your z is. So if you want to be 95% sure that the true population mean is somewhere in your interval, it's just going to be what you got in your sample plus or minus 2 times your standard deviation over root n. So notice, so now this gives us some insight. If we want to have a narrow interval, a really narrow interval, we really don't get to control the fact that the z is going to be 2 if you want to be 95% sure. We don't get to control the standard deviation. That's just whatever the data says. And we don't get to control this, not that that one matters. But if you want to be plussing and minusing a small number, the only way to make this number smaller is to make n bigger, right? So once you fix your confidence level, the only way to get a narrower, more precise interval is to ask more people. The more and more people you ask, the narrower your interval is going to be, and therefore the more precise your estimate's going to be, while still being 95% sure that the truth is within that. So that's basically how you find, the confidence interval. And again, Stata does, there's a command in Stata that can do it automatically to get that range. But again, conceptually, that's what's going on. So just to give a practical example, if you know that the average test score was a 400 and your standard deviation was, let's say, 40, and your sample size was 100 students, and you wanted to get a, so again, what this is saying is you asked 100 people, hey, what was your SAT score? What was your SAT score? And you got an average of 400 for those 100 people, and you want to now report, what's the true average? What's a range that we can be pretty sure that the true average is within that? And let's say we're using a 95% confidence interval, and we're rounding that to 2. Well, then we're going to say that our confidence interval, CI, or 90% confidence interval, 95% confidence interval, is literally our x bar plus or minus our 2 times our standard error, which is just going to be, let's see, 40 over root n, and the square root of 100, that's going to be 10. So root 100 is 10. 40 divided by 10. All right, so this 40 divided by 10 is going to be 4. And 2 times 4 is 8. So this is, you would then write this as 400 plus or minus 8, which you could even finally then report as 392 to 408. So long story short, the practical purpose of a confidence interval, and again, software can do this in a sec, but at least it's good to see once where this is coming from. But essentially, your sample was like, oh yeah, the average was 400, but if you want to not just report a single number, but rather a range, you would say, yeah, well, we're 95% sure that the true average SAT score is some number between 392 and 408.